Experimental determination of coefficient of apparent expansion. Experimental determination of coefficient of apparent expansion. The relation used is gamma A is equal to m2 minus m3 divided by m2 minus m3 divided by m3 minus m1 into T2 minus T1, m3 minus m1 into T2 minus T1. This is the relation used. On the right side we notice a specific gravity bottle filled with a liquid. Now let us try to understand the different terms used in this relation. Mass of empty specific gravity bottle is m1. So without filling the bottle with the liquid, we take its mass and it is taken as m1. Mass of specific gravity bottle plus liquid, it is taken as m2. Mass after completely filling the bottle is m2. Mass of specific gravity bottle with the remaining liquid, after heating some liquid flows out, and with the remaining liquid the mass is considered as taken as m3. The initial temperature of the liquid is taken as T1 and the final temperature is taken as T2. Initial temperature is T1 and final temperature is T2. Before we understand the procedure, now let us try to analyze this figure. In this figure we notice a cylindrical glass vessel containing water and it is placed on a tripod stand. This water is heated using a Bunsen burner, and in this water a specific gravity bottle filled with liquid is suspended from a retort stand. So retort stand, specific gravity bottle, suspension thread, spherical glass vessel containing water, and tripod stand and heating Bunsen burner. Like this we have to understand different parts of this figure. The procedure for determining the apparent expansion. We take an empty specific gravity bottle, it will be cleaned and made dry, and then its mass will be determined. Let us suppose its mass is m1. So the mass of the empty specific gravity bottle is determined with a common balance and it is taken as m1. Then we take a liquid at a temperature T1, we measure the temperature of the liquid and the liquid is taken into the specific gravity bottle. The bottle is completely filled with the liquid. Before filling the bottle with the liquid, we notice the temperature of the liquid. Say it is T1. So T1 is initial temperature of the liquid. After filling the bottle completely with the liquid, the stopper is fitted. The stopper contains a nozzle through which liquid comes out. So the spilled out liquid is wiped with a cloth. The spilled out liquid is wiped with a cloth and the mass is determined once again. The mass is determined once again and this mass is m2. This mass is m2. Then a thread is tied to the neck. A thread is tied to the neck of this specific gravity bottle. The specific gravity bottle is suspended from a retort stand and it is made to submerge under boiling water. It is submerged under boiling water up to its neck and it is held by a thread which is suspended from a retort stand. The liquid that oozes out from the bottle because of expansion of the liquid comes out of the bottle. That liquid is known as oozing liquid and it is removed with a blotting paper. If it falls in the boiling water, the boiling temperature of water changes. So the oozing liquid is removed with a blotting paper. The bottle is taken out when oozing is stopped. When the oozing stops, that indicates the expansion has stopped. The expansion has stopped when the oozing of the blotting paper stops. Then the specific gravity bottle is removed, it is taken out and it is cooled to the room temperature. Once again, the mass of the bottle is determined with the remaining liquid. This mass is called as m3. The mass of the specific gravity bottle with the remaining liquid is m3. then the temperature of the boiling water T2 is noted. The temperature of the boiling water T2 is noted. Derivation of the relation for calculating apparent expansion. While deriving the relation, we have to imagine for deriving this relation that initially we have taken the remaining liquid into the specific gravity bottle and its volume is say V1 and temperature T1. When it is heated to the temperature T2, it occupies the entire bottle, then its volume is V2. We have to consider the initial volume as the volume of the liquid, the remaining liquid. So, its volume is say V1 and its temperature is T1. Then when it completely occupies the bottle, its volume is V2 and its temperature is T2. The same mass of liquid occupies the entire bottle at temperature T2. So, V1 is at T1 degree centigrade, V2 at T2 degree centigrade. V1 is at T1 and V2 is at T2. Then V1 is given by M3 minus M1 by rho. M3 minus M1 is the mass of the remaining liquid, rho is density. So, M3 minus M1 by rho gives the initial volume of the liquid. When it completely occupies the bottle, its mass is M2 minus M1. M2 is mass with the bottle and liquid, M2 is mass of the bottle with the liquid and M1 is the mass of empty bottle. Hence, M2 minus M1 is the mass of the liquid. So, M2 minus M1 by rho gives V2, M3 minus M1 by rho is V1 and M2 minus M1 by rho is V2. The relation for cubical expansion or apparent expansion of a liquid is gamma A is equal to V2 minus V1 by V1 into T2 minus T1. The relation for apparent expansion gamma A is equal to V2 minus V1 by V1 into T2 minus T1. Let us substitute the values of V1 and V2 in this relation. Then we will get gamma A is equal to M2 minus M1 by rho, that is for V2, minus of M3 minus M1 by rho, it is for V1, whole divided by M3 minus M1 by rho into T2 minus T1, whole divided by M3 minus M1 by rho into T2 minus T1. Rho gets cancelled and in the numerator on simplification we will get M2 minus M3 and in the denominator we will get M3 minus M1 into T2 minus T1. Hence, the relation for gamma A is equal to M2 minus M3 divided by M3 minus M1 into T2 minus T1. The relation for gamma A is M2 minus M3 divided by M3 minus M1 into T2 minus T1.